Hello, everyone. I'm Valentina Rodriguez. I work with OpenShift and here at Red Hat. And today I want to welcome you to our OpenShift Commons general meeting. We meet every Wednesday at 12 Eastern Time. And what is common? It's really a place when we all meet from contributors and users, partners and customers, the people who work on OpenShift, everyone here just to discuss and have a great time sharing knowledge, listening to each other and collaborating. If you want to speak as well in this event, it's open to the public. So join our website that is listed on the green box and you can join and participate on any session as a speaker, but also just attend here and listen to any of our amazing topics that we have. So the other news is we do have super exciting news. As you can see in the screen, we have the opportunity to join us as an open source enthusiastic in our OpenShift Commons gathering in Salt Lake City this year, alongside KubeCon in November 12th. We are looking for speakers as well. The CFPs are open to the public, so feel free to submit your talk. The links are listed on the screen. And also, please register. If you just want to attend the session, you will have the opportunity to hear from many contributors, the community as a whole, about different topics, collaboration sessions, and many other things. So, yeah, stay tuned for more topics and the agenda. We will publish it there soon. Today with me, I will stop sharing my screen. Today with me, I have amazing speakers who will be talking about demystifying and enabling workload identity across the cloud native ecosystem. So Anjali and Andrew Block and Maia are here with us today to talk about this. So I will pass it over to you, and please feel free to introduce yourself and share your screen. Thank you so much.
Thank you, Valentina. Hi, everyone, and thank you for giving us the opportunity to present on workload identity. And super excited to hear feedback, to hear your questions, and also to share about workload identity and our thoughts and our proposals. So um, I am going to share my screen, Simon. Okay, yeah, that's fine. Let me know if you can see my screen.
Yes.
Okay. I think I'm going to start off with introductions. I'm joined with my co-speakers here, so we want to just briefly introduce ourselves and then dive into the topic itself. I am Anjali Telang. I'm the product manager for OpenShift Authentication, and very interested in talking about workload identity and how we can simplify it for our customers and for users of the cloud native ecosystem. With me today is Mariusz Sabat. I pass it on to him. He's from IBM Research. So, Mariusz, would you like to introduce yourself?
Hello, everybody. My name is Mariusz Sabat. I'm the senior technical staff member in IBM Research, and my interests are in multi-cloud identity, and I've been with research for 25 or so years. Thank you. Next to Maia.
Yes, hello, my name is Maia. I also come from IBM Research. I've been at IBM Research the past 2 years, always working on workload identity with special interest in SPIRE and the multi-cloud problems. I'll pass it to Andy.
Hey everyone, Andy Blanc, Distinguished Architect in Red Hat's Global Services Office of Technology. I work with our customers on focusing on several areas, one of them being security and especially emerging tech. So you're going to hear about some really cool emerging technologies coming out of the cloud native ecosystem today.
Awesome. Thank you, Andy. We don't have Trilok Geer with us today. He's busy. Also, it's very late for him. He's from India, but he has contributed extensively to this project. So big shout out to Trilok as well. All right, I am going to start talking about our approach here. So let's start by first of all understanding why do we need identities for workloads. In traditional security models, in peripheral security, as you would know, there was always a networking firewall or some sort of networking construct securing your environment. And you would get a IP, you being the workload would get an IP, and that's how you would identify while communicating to another workload in the system. Now, as customers and as users are moving into the cloud native world and moving into the various cloud platforms, what is very important is that the peripheral security model is no longer sufficient. So, your landscape is quite wide, and the security posture also is quite different in a cloud model. And for this, the approach of zero trust security has been very popular recently. So zero trust security, what it really means is that not you basically you have to verify at all times, and you trust no one. So you at every stage you are verifying yourself, you're verifying your identity. And that's why workload identity is so important, because workloads need to represent themselves correctly and they need to be verified correctly. So that's the premise of workload identity in a multi-cloud environment. Let's look at now some of the some of the options that are there and some of the challenges that are there in Kubernetes and multi-cloud scenarios. So Kubernetes, OpenShift being our Kubernetes product, they provide service accounts for multi-cloud for workload identity. So a service account token is used to identify one workload to another, and that's great. Up until now, there were long-lived service account tokens. Again, these pose the same kind of problems that any long-lived credential will pose. So your credentials are effectively, prone to exfiltration attacks. Basically they violate the zero trust principle, because a lot of trust is placed on the administrator to store and manage the tokens correctly. It there is no guaranteeing how many times the credential has been shared. There is no sense of control over the blast radius. So the same kind of problems that you would see with any long-lived credentials on the system, you would also see in a cloud native environment. Now, bound service account tokens have come out recently, and these are really great, especially the projected service account tokens. That's a great option because they are audience bound, they are time bound. If you are using the projected service account token, you're volume mounting them instead of using a secret. And the kubelet will also rotate the credential for you. So that's a great option for a single cluster. When it comes to multi-cluster, then again, you have to have some other solution. So looking at some other solutions that are out there, various cloud providers such as AWS, GCP, Azure, they already provide some sort of workload identity federation with short-lived OIDC tokens. And these are great options. They are again short-lived, they are rotated, they are audience-bound, time-bound. So this is a great option to have as you look into implementing your solution. But there are some challenges with these cloud federations or the cloud federation model. And some of the challenges are highlighted in red here, and I would like to just briefly talk about it. So when you have various clouds, what happens is that each cloud has their own schema of defining identity. And there is their own schema of providing trust, universal trust and relationships and access policies across the cloud. So what happens is one cloud will have their own definition of schema, another will have their own IAM policies, IAM schema, and you have to work basically across these clouds. So what does this really mean? Why is this such a challenge? Well, the reason this is such a challenge is because when you are doing these configurations across one cloud, It's complex enough. But then when you have to take this and multiply it into the number of different cloud platforms that you want your applications on, this becomes even more complex. And by complexity, you're talking about automation that you have to provide, configuration you have to provide, policy management, trust distribution. All of those things need to be done correctly. So you need a lot of resources, not just tooling and software resources, but also human resources to support the system. So like I said, doing the workload identity or doing identity in a single cloud is hard. You have to make sure that you have the right policy enforcement points. You have to make sure you have right authorization policies in place. You have to make sure your trust is configured correctly, your CAs are configured correctly, your certificates are rotated, and the credentials are stored correctly. So it's a complex system in itself when you look at a single cloud. And then this is what a multi-cloud would look like. So if single cloud is hard, then multi-cloud is even harder, because now you're, what you're trying to do is you're trying to configure these 3-4 different clouds. You're just seeing 2 clouds in this slide right now, but just imagine that you have to multiply this effort for all the different clouds that you support, including on-prem. So on-prem is also one of the cloud postures that you have to deal with, and you may have your trust on-prem that you would want to use or reuse or federate across these clouds. So then this becomes a very difficult model to sustain. Okay, we talked a lot about the problems of multi-cloud identity. So let's talk about the solution. So we bring to you a solution in the form of open source projects, Cloud Native Computing Foundation projects, SPIFFE, SPIRE, and Tornjak. SPIFFE is the standard, the format to providing workload identity. It defines what the workload identity will look like in the form of SPIFFE IDs, which are SWIDs, which are verifiable identity, cryptographically verifiable identity documents. And SPIRE is an implementation of SPIFFE. SPIRE will provide you with organization-wide SPIFFE IDs. It will provide you with issuance, rotation of your identity token, and a single point of federation with OIDC that you can use across clouds. More details on this, will be discussed by Mariusz. Mariusz is going to deep dive on the architecture itself. And you can see how SPIRE with its various plugin and just adds to the ecosystem. You can add various use cases by using these plugins. So Mariusz is going to deep dive on that. And one of those is Tornjak. So Tornjak is also an open source project which is being worked on very actively by Mariusz and Maia here. It provides a very nice control plane for SPIRE. It gives you a nice visualization and management capabilities on the cluster. So if you remember the slide we had gone through a few minutes back, where it was so difficult to get through the different pieces in the multi-cloud system. Now this is a little bit more simplified. Now you have SPIRE as the solution that provides universal identity, an identity format, and also the implementation of it across the clouds. I will let Mariusz take over on this and deep dive a little bit on the SPIRE architecture. Mariusz?
Thank you.
Okay, great. So let's go to another slide, please. And okay, yeah, let's start in here. So thank you, Anjali, for describing what the problem is, and we'll now talk about the solutions. So SPIRE, as mentioned by Anjali, it's the interface for managing identities. So let's take a closer look at it. So if you look at the top left corner, there's the SPIRE server there. So the SPIRE server job is to mint SPIFFE IDs. And these IDs are coming in form of the X509 certificates or JW-JAT tokens. And SPIRE contains certificate authority for minting, or it can be connected to the upstream authority, something external, for example, organization level CA. So minted identities are distributed to SPIRE agents, but before the SPIRE agent can be trusted, it needs to be attested. So the attestation can be done on through different plugins, like for example, through the cloud provider service or through standalone. There's also Tornjak, which is running right next to the SPIRE server, and it can provide the user interface to SPIRE. So when Tornjak user management is enabled, it can control the access to SPIRE and also provides remote access to SPIRE APIs, so they can be securely accessed remotely. SPIRE also has OIDC discovery service, which provides the implementation of the subset of the OIDC discovery document that relates to exposing public keys for verification of the JWT tokens that would be presented by workloads. There's also a SPIRE controller manager that allows workload registration with SPIRE. So in other words, each pod that is created in this environment and managed by SPIRE would automatically get its own identifier, its own ID. Okay, so that's the top part. If you look at the bottom, we have these agents, SPIRE agents, and they are running as a daemon set, which means one agent per worker node for each node that is hosting the workloads. And there's also attestation plugin, and we'll talk about the attestation on the next slide. So in addition to the node attestation that verifies the node, there's also a workload attestation that can validate the workload, the process that is running in this environment. And lastly, we have a CSI, the container storage interface, to manage access of the workloads to agents, so they could access identities without elevated privileges. Okay. So now, if we have a workload that is represented by this green box, workload now can obtain its own identity. Once it has this identity, it can present to some external entity. In this case, this is IAM, for example, in AWS, that is controlling access to S3 storage. So it presents this identity together with the request and says, hey, that's me. Can you trust me? And the identity on the other side, which is the IAM, can go and verify this identity token with OIDC. And if everything matches, then it looks at the policy. And the policy would say, is this specific workload allowed to access a specific resource? Okay, so that's the whole idea behind SPIRE. So let's go to the next slide, please. This is a view of our Tornjak. So the Tornjak is this graphical user interface for SPIRE, and it also functions as a control plane for SPIRE. So this UI, it makes it much easier to manage the SPIRE identities, and you can do it remotely, so you don't have to be co-located with the SPIRE server. And you don't have to use the CLI to access it. You can just use user interface. And we have multiple sections here. So there's a section that describes all the agents, you have entries, and so on. So basically, this is like a representation, graphical representation of everything what SPIRE delivers, but in a way that is easily consumable. All right, let's go to the next slide, which is should be this SPIRE node attestation. Okay, so the SPIRE nodes have to be attested before they can be trusted. So attestation happens for each individual node, and there are different methods to do it. So the simplest ones are the ones that are tied with the cloud provider. So there is a plugin for AWS, there's one for Azure, for GCP, and so on. But in addition to those providers, you can also attest using Kubernetes service accounts, which the projector service accounts tokens are the recommended alternative for the cloud providers. So node attesters basically verify what the node is and can validate this with some external entity. Another thing to do this is through X509 certificates, proof of possession. So if this node has something specific, which is in this case certificate, that can be verified and trusted, then the node is assumed to be trusted as well.
Is there a way to kind of sum the image? It's kind of small right now. I don't see the details.
Can
Okay,
we go to full screen mode,
Yep.
Anjali?
Yeah, yeah.
That might help.
And also, I was asking on the chat, like if people have been, aware of SPIRE. Some of them said that they do, but didn't have this amount of detail. And Greg was saying that yes, they are using it, so it's great.
Is this better? I tried to.
We can also make the charts available right after the call, so
Yeah.
it would be they can be easily zoomed in. And yeah, that's actually good feedback for the future. We should fix this slide to show the text a little bit bigger.
But you did a good walkthrough, so that's good. Thank you.
Yeah. But the main idea is that there is we basically have a method for validating the node, whether the node can be trusted, right? And this whole process happens out of bound. So in this case, we're looking at AWS, and AWS can be contacted, and we can verify that this is in fact the node that we think it is. And like I was saying, so this is for the cloud provider, but there are some other methods, right? If you have this on-prem, or if you have your own cluster that you own, then it's difficult to do it through the environment, but you can out of bound deliver specific certificate, for example, right? And if this certificate is present on the machine, then we can assume it's trusted. And there are even more advanced methods, like for example, there's a whole work that is happening with Keyline. So there is the remote attestation that validates how the machine was brought up, the whole bootstrap process, whether all the libraries were installed, and so on. This work is not completed. It's still happening, but I know that Red Hat has been pretty active in the Keyline attestation. All right, let's go to the next one, which is the workload attestation. So workload is something similar. So once we trust the agent, once we know that the trusted agent on a trusted node can easily communicate with the SPIRE, now we have a methods and plugins to attest the workloads themselves. And there are multiple different ways of attesting workload. One is using the Kubernetes, using Docker, systemd. There is an operating system attestation that validates process and ownership of the process, and that's done on the level of Unix and Windows, and so on. Yeah, I think that's all we can cover here. Let's go to the SPIRE Federation. So if there are any questions, I'm happy to come back and we can go over this in details. So SPIRE Federation. So SPIRE Federation is used to bring together 2 or more SPIRE instances that have different trust domains. So that's pretty helpful if you have 2 different organizations and they would like to communicate with each other and exchange their identities. Or you have one organization, but maybe 2 different groups or 2 different administrators, and each one of them is managing their own SPIRE server that has its own root CA. So when you are in a single SPIRE environment, it's relatively easy to produce identities and then verify them and make sure they are in fact coming from the same entity. But if you own 2 separate ones, it's actually pretty hard. So you have to exchange the security bundle, and this has to be done in a very secure way. So now I can trust the identities that come from a different location, because now through the federation, I have a way of validating these identities by exchanging the security bundles. Okay,
There
so
is
we
a
have.
question on the chat.
What's the question? Let me take a closer look.
Dwayne is asking about confidential containers.
It's complementary. Confidential containers is just one way of providing an environment for containers to operate. You then have the individual communication between multiple containers. Mariu's talked about some of the typical use cases where you have just one cluster where you need to go ahead and communicate between services within one cluster, but then you're also going to have many services that need to communicate among other clusters and services running across the different, as we see with many of our customers, they're running more than one cluster. You're not throwing everything into one cluster. You're typically communicating not only with different OpenShift clusters, but you're communicating with external services as well.
And just to add to what Andy said, confidential containers are typically black boxes. So from the point of view of the environment that is hosting confidential containers, they just see black box. They don't know, they have no access to it. But still, this black box has to have its own identity, has to somehow identify itself, where I am executed at, what's the location, what's the data center, for example, right? So you need to somehow bring this confidential computing to something that you can trust. And often this is done through maybe hardware root of trust. If you have TPM associated on the level of the bare metal, then you can map this TPM to the location where this host is residing, and then this black box, the confidential computing, can somehow identify that I am in fact running on this hardware, right? And from this point, you can trust me. It has to have its own location. All right, I think enough on about federation. Again, we're happy to do deeper dives as needed, but since we have so much more material, so let's go to the next slide, please.
Yeah, I think this is actually a perfect segue to talking about use cases. Use cases are something we are still exploring, and the feedback that you gave, the questions that you ask, is definitely going to help us bring these use cases together with Spire. As Mariusz talked about, integration with TPM, integration with Keylime is something we're going to talk about in the use cases section. But we are exploring these use cases. We are exploring ways in which Spire can contribute to the security posture in zero trust environments. And we've identified some of them that we want to talk about today, but there are lots others, and we welcome your feedback. If you have use cases that you want to discuss more, that would be great help for us. So we talked a lot about multi-cloud scenarios. So this is something that we want to explore, is federation between the different clouds. So if you have workload running on, say, an Azure cloud that wants to talk to a workload in a GCP cloud, they are either running on OpenShift or on some other Kubernetes platform. How do you federate the trust between these two environments? Using Spire is something we would want to explore a little bit more. That's on our radar. Another interesting use case is with Sigstore, and Sigstore is a project that's also open source, and that is something that is getting a lot of focus because of secure supply chain. Andy Block here has a lot of experience with that, and in fact has a great demo. Maybe at some point we can just deep dive on that particular use case, where the worker nodes that are doing the the signing and the verification of your artifacts, those as well get a SPIFFE ID. So that's how Sigstore can integrate with Spire and provide an end-to-end secure supply chain for your products. Another one that we are still very much exploring, there's a question, does the extend to edge or far edge. Anyone wants to take that up?
You can operate anywhere, so absolutely. It can be either the cloud, we're talking a lot. Many folks talk a lot about going out into the public cloud, but in other ways is the opposite direction. We're talking as more and more customers and services try to get close to their customers. It's not going to be the public cloud. It's going to be working either in the manufacturing field, it's going to be in a retail store, and being able to secure those workloads is even more important because guess what? It is not in your data center. You lose that nice little cocoon. Network security is incredibly important.
That was my next slide. In fact, key lime and remote attestation. So that's a great question. Yeah, we want to explore more on the edge computing side, how we can integrate Spire with Keylime to not just make sure that the workload is attested, but also that the host on which you are deploying is a reliable host. So this is definitely going to harden the posture working together between Keylime and Spire at the edge. And I will go back one more. This is one of the use cases. Again, there are two different formats that you see here, and that's because we are still very much exploring this space, how to federate with your corporate identity provider. You have customers have either Keycloak or Azure AD, which is now Entra ID, different OIDC providers. How do we federate with Spire and make it seamless such that the identity tokens from the uh, uh, corporate identity provider can be used for accessing workloads? There are two approaches that I've presented here. One which is very straightforward, where the one that you see in the green box there, where the Spire tokens are exchanged and federated for Azure ID tokens, and then use that. On uh, the left side, what you see here with Keycloak is something which is extremely new. We found an interesting session that was presented in Cloud Native Security Con around transaction tokens. This is an area that we are still wanting to explore, how to use transaction tokens, where Keycloak has an ability to provide this service using the service provider interfaces and exchange a Keycloak token, a Keycloak access token for a Spire token. So that's something that we would want to explore more. And if you have any interesting use cases for this, please provide us feedback. We are trying to see how we can best integrate with existing tooling at the customer end using Spire. We already talked a little bit about Keylime integration. So yeah, more and more use cases around network access are coming up as well. How do we have seamless, network access, which is identity based, not just IP based and not just peripheral, as we had discussed before. There's Cluster Link is another project that IBM is driving, in which you can have identity-based policies while accessing resources across VPCs. So that's one other use case that we are trying to look into a little bit more. Mariusz or Maia, do you want to add anything to this?
This is very interesting. Yeah, Marius.
Yeah, I would just say that Cluster Link, this is still experimental. It's not publicly available, even though they open source, I believe, the code. So what it allows, it actually brings the secure link between two independent VPCs. So if you have your own private cloud here, and you have another private cloud there, Cluster Link allows you to create a secure pipeline between these clouds. And based on your own different policies, it either prevents or allows the workloads to have access. And they are using also Spire identity underneath as an additional way of identifying what this workload is. And based on this, there is a policy that says yes, you can go. No, you cannot go to access this other VPC. So think about the cluster link to be this pipeline, the pipe that opens up and connects your two independent clusters that are isolated. So it's just like a link between these two private clusters. Yeah.
Yeah. So yeah, exactly. So non-internet facing VPCs, connecting them and bringing them together. That's another use case we are exploring. Um, And of course, one of the very common use cases that we've seen is integration with Istio. This has been uh, out there in the community for quite some time. There are some folks that have used this, and we would definitely like feedback on this as well. In this case, Spire integrates with the STS, which is Secret Discovery Service API, and provides the credentials so that Envoy anytime wants to access any credentials will use the authentication from Spire for that. Also, one interesting thing that we are seeing being used with this integration of Spire and Istio is the addition of OPA Gatekeeper or any other policy engine. Spire provides you with the authentication for the workload, and these engines provide the authorization. And then that way you have an end-to-end secure discovery service with service meshes. So next, we wanted to highlight. So those were the
before you continue, no, this has been great, and thank you, because I was thinking about mesh and all of that, how that fits. So I know we are covering a lot of different tools, and I want to make sure that there are any questions that anyone has at this point. Yeah,
definitely. And please bring the questions. We are in an exploratory stage right now, so use cases are very welcome. As I said, these are things that we are looking to POC, and by POC, we are going to actually try to deploy them and publish a nice recipe for you to follow, so that you can try it out yourself and give us feedback. Based on based on this, we've already done some work. So we have done a single cluster POC, and I would like to hand over to Maia to talk about the POC in some detail.
Nice. I have a question. So
Sure.
if I am new with these products, right, I know, security is so complex, right? And we have many layers, and we have seen Spire acting on, this security gateway on these different layers. But if I want to start, if I am new, like, what would you recommend for someone who is new with this product, and where to start? What will be
this slide itself,
best
Valentina, excellent question, because actually we are on that slide. We have published a tutorial. You can use a single node OpenShift. There's also work being done by Maia to bring this to kind clusters. It's a very simple tutorial, step by step. You can follow exactly, and you should be able to run through this within an hour or less. And Andy and others have provided excellent documentation in the tutorial. If you follow that, you will understand the concept behind it also as you play around with the product.
In fact, if you can handle copy and paste, I think you can do the full tutorial. Copy, command, paste, copy, paste, and step by step, every transaction is being executed properly.
That's great. And that's anyone from the audience?
Anyone.
Yes.
That's perfect. So if you are here or watching this video, please try it and provide any feedback.
And we provide instructions for both OpenShift as well as something simple, vanilla, like kind or minikube, right? So there's a little distinction. There's a few commands that you would have to run slightly different, and it's all documented, and it will be publicly available soon. So you can just follow the steps, and you can execute the same transactions.
That's great. Perfect. Okay. Now is demo time.
Oh,
I don't know
yeah,
if
we
it's
won't
demo
be
or you just want to
having
walk through the
Yeah, no
slides.
demo, just talking right
Just
now.
talking.
Yeah,
Okay,
we
that's
want to let you
perfect.
guys do the demo. So,
Yeah.
so on the next slide, just to whet your appetite for the demo, we present this scenario where there's this application calling to a database, very, very simple. And I guess this has been developed by Bob, who is a developer and who created this. And Kaya is the administrator of this cluster. And I guess she's pretty concerned about this particular detail where the application is using a credentials that are stored in a config map. So this is kind of the story of how Kaya transforms this insecure deployment into dynamically secured application access. So what we will walk you through in the tutorial is to deploy this insecure application first. And then on the next slide, what are the things that we need to deploy in the following slide with or the previous slide, sorry, SPIRE and Vault. So SPIRE is what we've been talking about this whole time. It's the thing that's giving us this cryptographically verifiable workload identities. And Vault is the other part of the solution here. And Vault is a really great tool for when, say, the applications are very difficult to modify or change. So in certain cases, maybe these applications haven't been developed to be SPIFFE aware or able to interpret SPIFFE identities. So Vault is a really great tool for kind of working around that, so that instead of storing credentials in a config map, we can store the credentials securely in Vault. And then we will, because Vault has really great integrations with SPIRE, Vault does enable the secured application access. So on the following slide, we take you through not just the deploying of these tools, but also the I guess the walking through of how a sidecar container can obtain the credentials from SPIRE, obtain the SPIFFE identity, and then use that SPIFFE identity to access Vault, which can understand these SPIFFE identities and obtain those credentials based on its SPIFFE ID, and we'll be able to put those credentials eventually on the application. Okay, so yeah, there's the flow. It's very, very simple, and we definitely recommend everyone to try it out. It's definitely publicly available, and is I think it's linked to in these slides that will be available. So next, I'll just hand it off to Andy, who will also talk about some other ways to get involved.
The most important part, going to the next slide. So can you just do a quick refresh, Anjali, of the slide?
Yeah,
just do F5. So the most important part, we talked about a lot of things here in this.
Give me a second.
Click on slideshow. No, hopefully work.
Give me a second. I'll just refresh and represent.
No problem. Most important part is we talked about a lot of things here, but getting involved, understanding these concepts, trying it out yourself is the most important part. And that's what we're going to provide you here is links to take what we talked about today and actually implementing it in either your own environment or just providing more understanding about these concepts. I'm not gonna lie. These concepts are foreign for many individuals. It is hard in many ways, but through the different tutorials and different topics and tools that we're going to provide, you should be able to get up to speed in no time. So the first thing we have out there is, if you're interested in learning more about the open source project, go ahead and pop up to SPIFFE.io. You can not only learn more about just the project itself, but all the different concepts, because these concepts aren't specific to SPIFFE or SPIRE. They are going to be ones that are being used in many different areas of cognitive computing. We published a blog that kind of introduced SPIFFE and SPIRE, so definitely check that out. It got published about a month ago. Now, if you want to get involved and learn more, there are two ways that you can do that. One, explore the learning path. Trilok, who we mentioned earlier, isn't on the call today. He spent a lot of time putting together the entire learning path that not only introduces these concepts, but allows you to walk through the steps to getting it running in your own environment. And then finally, if you want to play around with the hands-on workshop, go ahead and be able to try just another way that you can do this in a very simple copy paste, as Marius mentioned earlier. It's dumb easy. Honestly, if you just follow the steps, a robot can do it. And that's the best part about it, because it almost guarantees success in your environment. And then most importantly, the last thing I'll say is the power of the community is what brings us all together. And to be able to leverage the security SIG that we have within OpenShift Commons is the way to continue the conversation. I am one of the leads of the security SIG, and I work very closely with Valentina to be able to promote different ways of not only collaborating with all of you, but providing vehicles to have each of you collaborate amongst each other. We're here to provide the breadcrumbs. It's you all that goes ahead and provides the egg to bring everyone together and bind each other. So sorry for the dumb analogies, but hopefully that worked out well. So once again, thanks a lot for allowing our team to present to you all. Hopefully you learned something new today, and we can continue the conversation from there.
Yes, thank you so much. And please, if you join the SIG, as Andrew said, there in the website. We are also on the Slack. So through the website, you can also join on the Slack. We are all there. If you have any questions and wants to connect at any time, or just talk and chat, we are there. Just please feel to join us. Thank you so much, everyone. This has been fantastic. Any other questions before we stop the recording? Okay, awesome. Yeah, it was fantastic. Okay, stopping the recording. Thank you so much. I will see everyone on Wednesday, next Wednesday. Thank you.